Hey everyone, we are going to get into section 6.5 today on properties of special parallelograms. If you hear a little bit of noise, I am actually sitting outside. It's 63 and beautiful today, so I'm really enjoying the weather today. And if you hear my dog whining, this time it is because he sees the cows and cannot get to them. So you might hear a little bit of his whimpering today. All right, so section 6.5 is on properties of special parallelograms. Hopefully we can get this all in one video, but it's likely that it will be in two. Okay, so all of the properties of parallelograms previously discussed pertain to each of the special parallelograms that we're going to talk about today. So each of them that we're talking about today, the opposite sides are parallel, opposite sides are congruent, consecutive angles are supplementary, opposite angles are congruent, and the diagonals bisect each other. Okay, so each of the three figures that we are talking about today are just special types of parallelograms, so they do have those same properties. The first one we're going to talk about today is a rhombus. All right, so a rhombus is a parallelogram with four congruent sides. The diagonals are perpendicular to one another, so that's a little different than just regular parallelograms. And the diagonals are angle bisectors. Okay, so in our first example, it says find the measure of angle ADE. So if we look at angle ADE, that's this angle right here. The only angle that we are given is this 53 degrees. Now, if we look at the very last property we talked about, the diagonals are angle bisectors. If this angle is 53 degrees, that means this angle is going to be 53 degrees. Okay, so that helps us a little bit. We also know that right here is 90 degrees because the diagonals are perpendicular to one another. And then we have a nice little triangle here. Okay, you can see this triangle. So if we do 180 minus 90 minus 53, I believe we get 36. Let me think about that. 90 minus 53. Yes, we get 36. So the measure of angle ADE is going to be 36 degrees. All right. The second example, it says, what is GH? Okay, so in the end, we want to find this piece. Now, we see that this piece over here is 3x plus 1, which means that this side is also 3x plus 1 because those sides are congruent. Okay, so whatever we find for HJ is going to be the same for GH. Now, we don't have anything to set this equal to or anything like that, so we are going to look at these two pieces of the diagonal. So remember, diagonals bisect one another. So when a diagonal bisects, it makes two congruent pieces. Okay, so we can do 2x plus 3 equals 4x minus 7 and solve for x. So subtract 2x on both sides. Subtract that 3 on both sides. Oh, sorry, not the 3. Add the 7. There we go. Add the 7 on both sides. So we get 10 equals 2x. Divide both sides by 2, and we get 5 is equal to x. So first, before we plug that in for HJ, we want to plug it in for these two pieces right here of the diagonal to make sure that we did it correctly. So 2 times 5 is 10, plus 3 gives us 13. And then 4 times 5 is 20, minus 7 also gives us 13. So we know that we did it correctly. So now we can plug it in because we know that GH is equal to HJ, which is 3x plus 1. So we can do 3 times 5 plus 1. So GH is going to be 16. Each of those sides is actually going to be 16 because a rhombus has all congruent sides. All right. In our next example, okay, first I should probably put that this is a rhombus. Okay, so all of those sides are congruent. We want to know what is MNO. We want to know this whole angle measure. Okay, if you remember, in a parallelogram, consecutive angles, so these two angles right here are going to add up to equal 180. In a rhombus, we know that the diagonals bisect or cut in half each angle. So if this piece right here is 62, that means this piece over here is going to be 62. So this whole angle right here is 62 plus 62, which is going to equal 124. Now, since these two angles add up to equal 180, we can do 180 minus 124, and that is going to give us 56. So all of this angle right here, MNO, is going to be 56 degrees. All right, in the next one, we need to find QT. Buddy, here. All right, so we are looking for segment QT in this rhombus. So again, each of our sides is congruent to one another. And we know that this whole diagonal right here is 5y minus 4. So we know half of that will give us QT. But first we need to find out what y is. So we're going to take both of these sides and set them equal to one another. So we have 3y minus 1 equals 2y plus 3. Subtract your 2y on both sides. Add your 1 on both sides. And we get y is equal to 4. And of course, just like normal, we want to plug it in and check it. 3 times 4 is 12, minus 1 is 11. 2 times 4 is 8, plus 3 is 11. All right, so first we need to find QS because QT is equal to half of QS. QT is half of that diagonal. And remember, the diagonals bisect each other. So QS is going to be 5 times our 4, which is 20, minus 4, which is 16. So QT is half of 16, which is going to be 8. So QT is 8. All right, the next thing we're going to talk about is rectangles.